Hello everyone, Assalamualaikum warahmatullahi wabarakatuh and good day to every one of you. Welcome to my video. So basically this is a lecture video on the chapter of induction machines. Okay, so my name is Dr. Nur Zulaili binti Muhammad. Here is my email address. So you can just feel free to email me whenever you have a question regarding the content of this video. Okay, so next we are going to see the list of contents that we are going to cover in chapter 3. So the first subtopics is the constructional features, where we are going to see on how to construct the induction machines, okay, and then we will see in details on types of induction machines available in the market, alright, and then after that we are going to see the operation principles of the induction machines. Okay, so we will see on how does the induction machine works. Okay, and then after that we are going to see the three modes operation of the induction machines. Okay, so basically we have three different modes of operation. The first operation is a generating operation. The second one is the motoring operation, and then the third one is the braking operation. Alright, so and then after that we are going to see the equivalent circuit model for the induction machines. Okay, so basically the circuit model is similar to what we learned in the previous chapter, which is in the transformer circuit model. Okay, and then after that we are going to see several tests, which is no load test, block rotor test. Okay, so basically these two tests is used to determine the equivalent circuit parameter for the induction machine. Okay, and then after that we are going to learn on how to calculate the performance characteristics. Okay, so this will be include the performance such as the voltage the voltage regulation, the efficiency of the induction machines. Okay, and then after that we are going to see on the power flow diagram. Okay, so in this subchapter we are going to learn several types of power related to the induction machines. Okay, and then the last but not least we are going to see the effects of rotor resistance. Okay, so in this subtopic we are going to see what will happen to the performance of the induction machines when we have various different value of the rotor resistance. Alright. Okay, so basically in this video we are going to cover only the first subtopics, which is the constructional features, and then the rest of the subtopics will be covered in the next following video. Okay, so let's move to the first subtopics, which is the constructional features. Okay, so first of all, introduction for the induction machines. So the induction machine basically is the most rugged and the most widely used machine in the industry. Okay, in terms of the construction, it has a stator and a rotor mounted on bearings and separated from the stator by the air gap. Okay, so stator is a static part, and then the rotor is a moving part in the induction machines. Okay, and then both stator and also a rotor is separated by the air gap. Okay, alright, and then basically the rotor is mounted on the bearings. Okay, and then both stator winding and also the rotor winding carry the AC current. Okay, for the stator winding, the AC current is supplied directly to the stator. However, for the rotor winding, the AC current is supplied by the induction. Okay, so that's why we call it as a induction machines. Okay, so we will see in details later what does it means by the AC current supplied by induction, and then what does it mean by the AC current supplied directly to the stator winding. Okay, we will see in detail in the next upcoming slides. Okay, alright. And then the induction machines can be used both as a motor or it also can be used as a generator. However, it is most frequently used as a motor in many applications. Okay, so even though it can be used either as a motor or it can be either used as a generator, but it is frequently used as a motor in many applications. So the majority of the motors used are squirrel cage induction motors. Okay, and then the induction generators are seldom used. Okay, their typical application is in renewable energy applications only. Okay, the induction motor is used in various sizes. Okay, so basically we have three different sizes. You can either have a small single phase induction motor, or you can also have a two-phase induction motor, or it can be either large three-phase induction motors. Okay, so for example, for the application, usually for the small single-phase induction motor are used in many house appliances such as in blenders, washing machine, and also refrigerators. Okay, for the two-phase induction motors are used primarily as a servo motor in a control system. Application for the large three-phase induction motors are used widely in the industry, such as in pumps, fans, compressors, paper mills, textile mills, etc. Okay, so this is an example of application for the induction motor, where we have various size of the induction motor. Okay, so basically there are two forms of machine dependent on the rotor winding. Okay, so the rotor winding can be either as a squirrel cage rotor, or it can be either as a wound rotor. Okay, so meaning that there are two different type of rotor winding. Okay, all right. So the first one we call as a squirrel cage rotor. So here is the construction of the squirrel cage rotor. So for the squirrel cage winding, it consists of the aluminium or copper. So this is the one that attached in the middle. So it consists of aluminium or copper bars that embedded in the rotor slots and shorted at the both ends by aluminium or copper end rings. Okay, as shown in here. Okay, so usually the rotor short circuit on the rotor itself. Okay, so we short circuit at the both end of the rotor. Okay, so the next type of the rotor winding is the wound rotor, or we can call it as a slip ring. Okay, so for the wound rotor, basically it has the same form as the stator winding, but the terminal of the rotor winding are connected to the three slip rings. Okay, so you just notice these slip rings. Okay, and then the rotor slip ring sliding connection is used for the external electrical connections. Okay, so for the connection of the this slip ring, it can be either short circuit, or you can also add extra resistance to the rotor by connected the external resistance to the slip ring. Alright. So the purpose of adding extra resistance to the rotor through the slip rings is basically for the purpose of speed control of the induction motor. Okay, so by comparing between these two, between the squirrel cage rotor and the wound rotor type, so it is obvious that the squirrel cage induction machine is more simpler, more economical, and more rugged compared to the wound rotor induction machine. So that's why you can see that many application people tend to use squirrel cage rotor compared to the wound rotor type. Alright. Okay, so basically the induction motor have a few advantage over other type of motor. So the first one, the induction motor is considered as a self-starting motor. Okay, meaning that it has no special starting equipment in order to start the motor. Okay, so whenever you have a stator and you have a rotor, and then you just need to apply the AC current to the stator part, and then the motor will be induced by itself. So that's why we call it as an induction motor, right? And then the induction motor also have a speed reversal plugging by reversing the phase sequence to the stator. Okay, meaning that you just need to swap over any two-phase connection for the three-phase induction motor, then you can have the speed reversal plugging condition. Alright, and then basically you know that in the previous slide, the machine has two types of machine, whether it has a squirrel cage machine and also it's a wound rotor machine. Okay, so for the squirrel cage machine, the advantage, it has no rotor electrical connections. Okay, so you don't need to have any electrical connection to the rotor, right? And then for the slip ring machine, you can use the external resistance to increase the starting torque and also decrease the starting current. Okay, meaning that you can control the speed of the machine by using the slip ring machine. Okay, and then after that, once you control the speed, once the speed reach the full speed, the slip ring machine will be shorted out. Okay. Okay, so this is the example of the single-phase induction motor that used in the electrical appliance, such as in the washing machines. Okay, so you can see that if you open up, let's say you just open up your washing machine, you can see this type of single-phase induction motor. Alright, so basically, usually the induction motor will be having a nameplate. Okay, so based on the nameplate, you can see the characteristic of the motor. Alright, so this is the capacitor. Okay, and then the rotor have a shaft. Okay, so basically the shaft will be connected to the external load. Alright, okay, so this is the terminal box. Okay, so this is the bearing house. Okay, and bell. This is the shaft. Okay, alright. And then this is the other type of the single phase induction motor. Okay, so same thing, you also have a nameplate. Okay, so it is a must to have a nameplate on the motor so that we can know the specification for the motor itself. Okay, so this is the terminal box. Okay, alright, so this is the shaft. Okay, so the shaft usually we connected to the load. Alright, okay. And then this is an example of for the industrial induction motor. So basically this is the three-phase type, three-phase induction motor. Okay, so for the industrial applications, okay, we use three-phase induction motor. It's used to drive the machine. So basically, maybe we use in the paper mill. Okay, maybe in the water pump. Okay, so this is the example for the three-phase induction motor, or we can call it as an industrial induction motor. Right. So you can see that the green color represents the housing. So usually the motor will be located inside the housings. Alright. Okay. So next, this is the example of the constructional feature of the induction motor stator. Alright. So this is example of stator of a large induction motor, meaning that this is stator for the three-phase induction motor. Okay. So this is the stator winding. Okay, you can see there is a lot of winding here. Okay, alright. So this is another type of the three-phase stator winding. Okay, so this is the static part. So usually we just place the rotor into the middle of the stator. Okay, so this is the example of the three-phase stator winding that we use in the industrial. Okay. So this is basically show you the rotor that connected to the previous stator. Okay, so this is the stator part. So this is the rotor part. Okay, so this is basically the example of the squirrel cage rotor. Okay, so where you have a single bar. Okay, so this is a single bar that short circuit by the end rings. Okay, alright. Okay, so this is another example of the squirrel cage rotor that showing bar just below the surface of the rotor lamination. Okay, so you have this is the rotor. Okay, so you have a rotor bar that short circuit at both ends. Alright. Okay, so this is another example of the stator winding for the previous machine. So this is the stator winding at the stator part. Alright. Okay, so this is the example of the slip ring rotor. Okay, so basically you see the constructional of the rotor. You can see the three different slip ring. Okay, so this slip ring can be used to connected to the external resistance in order to control the speed of the induction machines. Okay, so whenever you see the three slip rings, meaning that this is the type of slip ring rotor. Okay, alright. So this is another example of the slip rings of 250 kilowatt 8-pole machines. Okay, so you have a 1, 2, and 3 slip ring that connected to the rotor. So this is the rotor. Alright. Okay. Okay, next we will see the stator rotor construction details. Okay, so basically this diagram represents the cross section of the stator and rotor. Okay, so this is the stator part. Alright, and then this is the rotor part. In the middle is the rotor. Okay, so the stator part is actually the static part, and then the rotor is the one that moving in the induction motor. Okay, so you see there is a laminated, so this is the laminated iron core with slots. Okay, so you see this is the various slots that available. Okay, so basically the purpose of this slot is for you place the coil. Okay, usually we will place the coil in the slots to form either three-phase winding or single-phase winding. Okay, depends lah. If you want to have a three-phase induction motor, then you need to connect the winding in the three-phase connection. Okay, If you want to have single phase windings, then you can just connect the single phase winding at the stator part. Alright. Okay, so next in this diagram, it shows you the rotor construction. Okay, where you have a rotor bars. Okay, so this is the rotor bars that connected between the two end ring. Okay, so if you refer to the rotor construction, basically the rotor bar is slightly skewed. Okay, so why do we need the rotor bar to be slightly skewed? This is due to the phenomenon that we call as a cogging phenomenon. Okay, meaning that if the rotor and the stator is in parallel to each other, it will cause the magnetic force locking between the rotor and the stator. So that's why the rotor bar must be slightly skewed like this to avoid the cogging phenomenon. Alright. Okay, so next in this diagram, it represents the stator construction. Okay, so basically, for example, you have an iron core. So this is the cylindrical shaped iron core, and it has a laminated slots. Okay, so this is the various slots that are available in the stator. And then, for example, the white color represent the paper liner insulation that placed in the slots of the stator. Okay, so for the three-phase motor, usually we will place the three-phase winding in the slot. Okay, let's say you want to have a single phase motor, so it has two windings, meaning that the main and the starting winding will be connected in the slots. Okay, so typically the thin enamel insulated wire are used to form the stator winding here. Okay. Okay, so next this diagram shows you the stator iron core sheet. Okay, so basically you can see that there is 4 holes here. Okay, so basically the 4 holes is actually we punch from a silicon iron sheet. Okay, for example, here you have 4 different holes. Okay, and then here you have a 36 slots. Okay, so basically these holes and the 36 slots will be used for assembly of the winding. Okay, so you are going to assemble the winding through these holes and also these slots, right? Okay, so this is another stator iron core construction. Okay, so the figure show you typical stator iron core, where you have a laminated ring shaped core is bolted to the motor frame. Alright, so the coils, so this is basically the coils. So this is also represent the coils in the slot. Okay, so the coils are placed in the slot, and then the slots are closed by a wedge. Okay, so you see it closed by a wedge, and then the coil ends. Okay, so after you connect all the coils, the winding, okay, and then the coil ends are shaped to fit to the iron core and tied together by strings. Okay, so this is tied together by the strings. So this is an example for the stator iron core construction. Alright, okay. So next, for the rotor construction. Okay, so if you still remember in the previous slide, you know that there are 2 different types of rotor construction, whether it is a squirrel cage rotor or it can be as a wound rotor. Okay, for the first one, the squirrel cage rotor, the picture show you the rotor for the small and large motor. So this is example rotor for the small motor, and this is example rotor for the large motor. Okay, so both rotor have a laminated core with slots, okay, mounted on the shaft. So this is the shaft that connected to the load. Alright, so the aluminium bar are slanted on the small rotor. So you see this is a slanted. The purpose of the slanted is to reduce the noise and improve the performance. And then both rotor also have a fins. So this is the fins that located to the rotor. So this is also fins. Okay, so the purpose of the fins is works as a fan and improve the cooling for the rotor. Okay, the large rotor also have fins. Okay, but the bars are not slanted. Alright. Okay, so this is another example of the rotor details for the squirrel cage rotor. Okay, so when you see here, you have a laminated iron core that is slanted, and then here you have a fan blades. Okay, fan is the purpose for the cooling of the rotor. Okay, and then the rotor connected to the shaft. Okay, so basically the shaft will be connected to the output load. Alright, okay, so next this is the example of the construction of the wound rotor, the other type of the rotor. The first one we had C, the squirrel cage rotor, and then the second one is the wound rotor. So the picture show you the rotor of a large wound rotor motor. Okay, so for the wound rotor, you have a slip ring here. 3 different slip ring. The purpose of the slip ring, because you can connect the slip ring to the external rotor resistance. So the purpose of connected the rotor resistance is for controlling the speed of the induction motor. Okay, so the ends of each of the face is connected to the slip ring. So the 3 brushes contact the 3 slip ring to the 3 wide connected resistance. Okay, so the purpose of connected this resistance is to control the speed of the induction motor. Okay. Okay, next we will see the concept of the squirrel cage motor. So basically this diagram show you the cage rotor diagram. Okay, alright, so in terms of the construction, so this is the stator with the laminated iron core. So this is the stator part, alright, and then the one in the middle is the squirrel cage rotor. Alright, so the blue color represent the bars. Okay, so usually for the bars, the ring will be short circuit to the bar. Okay, alright, so this is the slot that we will going to put the windings. Okay, so basically for the 3-phase winding, okay, so you will be having a connection between the A plus and A minus here. Okay, so you'll be connected from here to here to form the phase A winding. Okay, and then for the phase B winding will be connected from B minus to the B plus. Okay, and then for the phase C, the winding will be connected from C plus to the C minus here. Okay, alright. So the stator has a ring shape laminated iron core with slots. Okay, so you have it can be either 3-phase winding or single-phase winding, dependent on what you need. Okay, and then the rotor also has a ring shape. Okay, laminated with the iron core with slots bolted to the shaft. Okay, for the squirrel cage rotor, the conducted bars are placed in the slots and short circuit at the both ends. So, and then the squirrel cage rotor is the most frequently used in the most of application. Okay, next we will see the concept of the wound rotor motor. Okay, so basically, in terms of the diagram of the wound rotor, it is similar to the squirrel cage rotor, except at the rotor part, at the middle part here. Okay, so this is the stator with the laminated iron core, and then you also have a slots for winding. Okay, and then this is basically the 3 color represent the red color, blue color, and green color represent the slip rings connected to the rotor. Okay, so this is the shaft that connected to the load, to the external load. Alright. Okay, so in order to form the 3-phase winding, so basically you will be having 3 different phase A, phase B, and phase C. So in order to form the phase A, you'll be connected the winding from A plus to the A minus. Okay, and then for the phase B, will be connected from B plus to the B minus. Okay, the winding will be connected from here to here. And then for the phase C, the winding will be connected from the C plus to the C minus. Okay, so the winding will be connected like this, and this. A, B, B, and C, C. Alright. In terms of the construction, the 3-phase windings are placed in the slots. Okay, we'll be placing the winding into the slots. Okay, the winding can be either Y or delta connected. It depends on the connection that you want. The ends of each phase is connected to the slip ring. So this is the slip ring connected to each of the phase. 3 brushes contact the 3 slip rings. Okay, the rotor winding may be loaded by variable resistance or supplied by a separate power supply. Okay, alright. So we had done C on the constructional feature of the induction machine. Okay, we will already see the cross-sectional area, how the rotor diagram, the stator diagram, and everything. So I think that's all for now. We will see in details on the operation principle of the induction machine in the next following video. Okay, so thank you for watching my video. Thank you for your time. I'll see you in my next video. Okay, bye.